So in this video, we're going to be building ourselves a Farcaster frame, and this frame is going to require that a user likes and recasts a cast in order to mint the NFT. So I'm in the frame validator here on Warpcast, and we're going to just load our frame here. So this is our test frame right over here, and you can see we have get started. And what this is going to do is first check to see if you have liked and recasted the cast that we are asking you to do. And then it's going to check if you have the NFT or not, because if you already have the NFT, then we're not only going to allow you to claim it once. And then if you don't have the NFT, you have liked and recasted the specified cast, then you'll be able to claim the NFT. So hit get started. And you can see here we have to like and recast to mint. So because this frame isn't published on a cast, I made it so that you have to like a certain cast on my profile. So right over here, you can see we have cast and recast. So I can just like it and recast this post right over here. Once I have liked and recast it, I can click on that again. And you can see here, now I am able to mint the NFT. So I'll hit mint. There you go. It says, congrats, the NFT was sent to your wallet. Now, this is using thirdweb's engine behind the scenes. And if I come over to my NFT contract here, we'll give it a moment. You can see right here, this is my wallet address for my Farcaster account. And you can see our NFT was claimed there. Now I own an NFT, so if I come back to that frame and I try this again, it'll say I already own the NFT and I won't be able to claim another one. Hey everyone, Sean Watasa here, back with another video. And in today's video, we're building a Farcaster frame to mint an NFT. But in order to mint the NFT, you're going to have to like and recast a cast in order to mint it from our frame. So an overview of what we're going to be doing in this video, we'll first deploy the contracts that we need for our NFT. We'll then build out our Farcaster frame and then test it in Farcaster. So with all of that being said, let's jump on the computer here and get started. So again, this is the frame that we're going to be building here. And the first thing we're going to do is deploy our smart contracts. So we're first going to deploy our smart contracts here. I'm on thirdweb's dashboard here. I collected my wallet and everything already. I'm going to head on over to the contracts tab and I'm going to click deploy contract. Now you can deploy any type of contract you want. For this tutorial and example, I'm going to be doing an NFT drop, which is an ERC 721 NFT. So I'm going to select that there and I'm going to click deploy now. Now we can fill out the contract parameters here from the name, symbol, description. You can upload an image and everything. I'm just going to call this tester. We'll just give it a symbol of test. And again, you can fill out your information here. Now I'm going to scroll down here and under network and chains, on this drop down here, you can select any EVM compatible blockchain. We support all of them and you just need to search them up. So let's say I want to use Mumbai here for this one. You can choose Mumbai, you can choose Base, Avalanche, whatever network you want to deploy your contract to, select that there and then hit deploy now. You'll get a transaction here that pops up. We just have to pay the gas to deploy our contract. So I'm going to hit confirm. You'll get another pop-up here asking for a signature request. This is so we can add the contract to our thirdweb dashboard. So we'll go ahead and sign that. And there we go. Once that has been successfully deployed, you'll be brought to your contract dashboard. You can see we have our tester contract here and our contract address. We'll need that later on when we're building out our frame. Now we're going to deploy lazy mint some NFTs to this contract here. So on the left-hand navigation, we're going to go into the NFTs tab. And I'm just going to batch load some NFTs here. I have some metadata here, but this is where you'll upload your metadata for your NFTs. So right over here, I have 15 NFTs here. They're just these little characters here. Once you have them uploaded, if you do a batch upload, you can hit next. You can reveal upon mint or you can do a delayed reveal. I'm just going to do reveal upon mint here and upload my 15 NFTs. We'll get a transaction here to pay for the gas. I'll confirm that. And there you go. We have our 15 NFTs minted to our lazy minted to our contract. Now, the next thing we're going to do is set up our claim conditions. Now, our claim conditions are going to be set up in a unique way because we're going to be using thirdweb's engine to do all the minting for us. I'm going to open up a tab of engine here. Engine is basically a backend HTTP server that calls smart contracts on behalf of the user using a backend wallet. So we have a wallet which we have stored the private keys and everything to, and we'll be able to use that wallet to call on-chain transactions whenever we get a request to it. So we'll open up our thirdweb engine here, and over here, we have some backend wallets. I have my backend wallet right over here, and we need to make sure that only this backend wallet can mint NFTs from our NFT or smart contract here. And in order to do that, we're going to go to claim conditions here, and we're going to add a phase, and I'm going to hit allow list only. Now here we can set how many NFTs are in our collection. So I'm going to say 15. We're going to say it's free. And I'm going to come here and we can edit a claimer snapshot. You can download these example CSV files, but I already have one made. And ideally, if we look at a preview of this CSV file just has the address, which is my backend wallet, and the max claimable amount that it can claim. So I'm just going to click and drag the CSV file here. You can see our address, max claimable 15. Price and currency, this is going to default to whatever we have set outside of here. And then I'm going to hit next. So brand price and currency default to what you have here. Now what this is going to do again is only allow our backend wallet to claim the NFTs, which we only want our backend wallet from Engine to be able to call the mint function from here. And we'll just send it over to the wallet that is connected to the Farcaster account. So I'm going to save this claim condition here. And we're going to confirm that transaction here to save this claim condition. And once this claim condition is saved, our NFT smart contract is set and ready for us to build a frame around. So right there, that is saved. And again, our contract is done. We can now start building out our application. So I'm going to come over to my terminal here and I'm going to start building out our application. Actually, before I do that, let's take a look at frames here. So if you want to learn a little bit more about frames, we'll link Farcaster's frame documentation down in the description below. Now we do also have another video that we did on frames. We'll link that down in the description below as well. You can check that out. We go more in depth on how frames work and everything. Essentially, frames work using a set of meta tags within the head tag of the HTML page. So with that, we're going to be using setting these meta tags with these keys here. You can see here we have some required properties that we need, and we have some optional properties that we can use in order to build these frames. Again, you can check out the other video that we did around Farcaster Frames if you want to learn a little bit more about how to set up frames and how they work. But we're going to come over to our terminal, and I'm going to run npx create next app, and we're going to call this a requirement frame project. And for this next project, yes, we are going to use TypeScript. I'm going to say no to the ESLint, no to Tailwind, yes to the source directory. I'm going to say no to app router for this, and no for the customizing the default import. Right, so we'll change into our requirement frame here. And we'll open this up in our code editor. And with that open, let's start building out our project. Now, the first thing we're going to do is in our source folder, we're going to create a new folder here, and we're going to call it config. And in that config, we're going to create a new config file. So we're going to call this config.ts. And we're going to set up some configs here. So we're going to export a config. And we're going to need a few things. One, we're going to be using something called a Neynar, and I'll come to here and show you folks what Neynar is. So Neynar here is an API you can use to essentially get some information from Farcaster. Now they do have a Frames API, which we're going to use to validate the Frames message. And we'll also be able to get information like if a user has liked, recasted, or followed certain accounts. So with that, with Neynar, we'll be able to check has a user actually liked and recasted the cast that we are asking for. And that is going to be our requirement in order to mint the NFT from our frame. So if we want people to share our frame, they can like and recast it in order to claim it. So with Neynar, we are going to need an API key from there. So we're going to create an API key. And this will be in our environment variable here. So we'll just say process.env. We'll call it Neynar API key. We'll need one for our contract address. So this is going to be for our NFT contract address. We'll make sure that this is a public environment variable here. So we'll put next public and then contract address. We're also going to need something from, we'll call it warpcast here. But we're going to need the cast hash. So this is going to be used so we know the cast that we're going to require a user to like and recast before minting. So we'll say cast hash. And then this will be our next public, we'll say warpcast cast hash. Next, we're going to need our host URL. This will be our next public, we'll just say host URL here. And then we're going to have some third web here. And one thing we're going to need is the chain ID. So this is going to be the chain that we deployed our smart contracts to. In my case, I deployed it to the Mumbai testnet, but this will be the chain ID that you deployed your contract to. So we're going to make sure that this is a number, and then we're going to get the next public third web. We don't need third web, we just need chain ID here. Then we have our variables that we're going to need for our engine. That is going to include the URL, which we are going to say is our third web engine URL. We're going to need our backend wallet, which is going to be our third web engine wallet. And then we're going to need our access token, which is going to be our third web engine access token. And this is going to be our config file here. And again, these are going to be all the environment variables that we're going to plug into. We're going to use Vercel here. So when we set up Vercel to host our frame here, we'll make sure that we add in all of these environment variables into there. Right. Next thing we're going to do is if we look at our frame here really quick, our frame normally has a thumbnail image here that will be displayed, and you can use any image. We're just going to grab one really quick from here. So I'm going to come back to my code editor, and I'm going to get our image and put it into the public folder here. So my image is just this light bulb here. It's going to be example image.png. You can use whatever image you want. You'll also be able to put multiple images and switch through and toggle the images based on the state of the frame, and we'll go over that in a bit. So now that we have our config file set, we added in our image. Let's go to our pages folder here, and we're going to go to the underscore document.tsx file. Now again, this is where the frames take place. This is what where you'll build most of your frames. We're going to build it within this head tag here. And within that head tag, we're going to add a bunch of meta tags, and these meta tags are going to be used to, again, create our frame. So the first thing we're going to do is add a meta tag for our OG title. This is going to be the meta tag for the title for something that is posted onto social media that isn't a frame. Same thing with this next tag here. This is going to be the OG image. So these are going to be the meta tags that are used when you're not rendering a frame, and say you post this link onto some other social media share page and you share it. These are the things that are going to show up here. So let's also import our config. So next thing we need to do is set up this frame to make sure that frames or Farcaster can detect it. So we're going to create a meta tag here with the property of FC frame, and the content is going to be vNext. And this is so we can specify that this is a frame here with the version. Next, we'll create a meta tag to display the image for our frame, and that's going to be using the property FC frame image. And the content is going to be our host URL / again, that example image that we just added into our public folder. Next, we're going to create a new meta tag here for our post URL. This is going to go to our API / mint file, which we are going to create in a bit. But this here is going to be the API that calls our engine and Neynar to check if a user has liked and recasted, whether they own the NFT or not, and then essentially to mint the NFT. And then finally, we're going to add a button here using the FC frame button. You have to index the button. You can actually add up to 4 buttons with a Farcaster frame. So we'll say that this is button 1, and what it's going to say here is get started. So I'm going to save that, and that is going to be the basic structure of our frame. So if I take a look back at our demo frame here, so if we look at our frame here, we have our image here, we have our button with our text, and then when we hit this button, that's where we're going to hit our post URL, and that's where we're checking again if a user has recasted and if they own the NFT or not. Now, next thing I'm going to do is come into my pages folder. We're going to just delete this index.tsx file, and we're going to create a new file here, and we're going to call this mint.tsx. So this frame here is actually a website, and if we were to actually click on this, it would bring you to the website or the URL that you're hosting here. And for this demo here, I just added some text that says like and recast to claim. You can add a link to the Farcaster Cast. You can build out your own web application, your own website here. Just when you share it to Farcaster, that frame is what is going to be displayed. So you could create some type of, again, Web3 application, website, whatever you want here. I just kept it simple and added some text. But we're going to need to create this page that people will go to whenever they directly go to the URL on like a browser or something. So in this mint.tsx file, I'm just going to copy some code here, and we're just going to call this our frame mint here, and then we have a div with some styling to center everything, and I just have some text that says like and recast to claim. Now we're going to need to make sure that a user is directed to this mint.tsx file here. So I'm going to open up my file directory here. This next config file, I'm just going to rename this to .js. And then I'm going to change our config file here just to redirect to our /mint page. And that will be where our users get redirected to if they just type in our URL directly into something like a browser. So now that we have those things set, again, this is where someone will land if they just go directly to the URL in a browser. These meta tags here are set to detect that this is a Farcaster frame and that this should show for the frame, including the image and button. Now we're going to create a file that is going to alter these meta tags depending where we are within our frame mint process. So in my files here, in my source folder, I'm going to create a new folder here called utils. And in that utils folder, I'm going to create a new file called compute.html.ts. And in here, I'm going to create an interface called compute HTML parameters. And what we're going to do is we're going to accept something called the post type, which is going to be a string. We're going to take the content, which is going to be a string as well, and then our image path. Then we're going to export our compute HTML. And this is going to take, again, our post type, content, and image path. And what we're going to do in here is, and in here, we're going to create our HTML file again. So we'll have our meta tags that we set up for our Farcaster frame. So we'll have our tag for our image where we can set up a new image path. So depending where we are within our frame, we can set a new image path if we want that to change. Same thing goes for our post URL. We can change the post type. So depending where we are within our mint process, again, we can check and set the post type to display different information. And then the button, we can display different content, whether it's in the mint process, you have to like or recast something, or if we're congratulating that someone has successfully minted an NFT. So this is where we're going to be able to compute and lay out our new meta tags for our frame. Let me just import our configs here. And there we go. So again, we have all of this set up. Now we just need to create our Mint API to figure out if a user has liked and recasted the specific cast that we asked them to do and allow them to mint the NFT using thirdweb's engine. So first, let's check if a user has liked and recasted our cast that we specify. So in our source folder here, I'm going to create a new folder. We're going to call this classes. And I'm going to create a new file here called warpcast.ts. And in here, we're going to set up our API for Neynar to check if a user has liked and recasted. We'll also set up to check that our frame, to validate our frame message. So first thing we'll do is we'll create a variable here called our API URL. This is going to equal the api.neynar.com. Then we are going to create and define our schemas for our reactions and then for our validate message. So we'll create our reaction schema here. So we'll just call this reaction schema. This, we're going to open our terminal really quick and we're going to run yarn add ZOD. And then once we have that installed, we can just say our reaction schema is going to be an object. And we're going to get our likes. And likes is going to give us an array. And within the array, we're going to have an object. And let's make sure we import this real quick. And that object, we're going to get back our FID number, which will be a number. And we're going to get back our f name, which is the Farcaster username, which will be a string. And then we also want to check our reactions for recast, which again will be an array. We'll get back the FID number and the f name, which is the username. Next, we're going to create our schema for our validate message, which will be an object as well. We're going to get back if the message is valid or not. We're going to get back our action here, which is going to give us back our interactor, which is going to include the FID number, the username, and the custody address. Below action, we're also going to get returned a tapped button, which is going to give us back an object as well. And it's going to give us back the index of the button that we tapped, which in this case, again, Farcaster Frames allows you to have 3 buttons. So we'll say a z literal of 1, 2, 3, or 4. Now that we have our schemas for our reactions and for our message validating, we're going to create a class for our warpcast here, which is essentially Neynar, and we're going to get and fetch our reactions and check if a user has liked and has recasted our specified cast. So we're going to export class here. We're going to call this warpcast. Now we're going to first just create our default header for our API since we're going to use it a few times. So we're going to create a private static async here called compute default header. And in here, we're going to return our default header, which is going to be our API key, which we are going to get from our config. It's going to be dot, did I do config? Wrong config. So from our config, we're going to get config.neynar.api key. And we're going to set the default content type to application JSON here. Then we're going to fetch all the reactions for the cast hash. So depending on the cast hash that we provide, we're going to check the response for it. So we're going to get our private static async, and we're going to say fetch all reactions. So in here, we're first going to get the URL to get all our reactions from, and this URL here is going to be our app URL that we have up here, which is going to be our Neynar API. We're then going to do v2/farcaster/cast identifier. We're going to get and provide our cast hash depending on the cast we want to check for. And then we're setting the type to hash because we're going to again pass it the hash here. So next we'll get our response here, and we are going to await fetch our URL. Provide it with our headers here, which is going to be this, which is going to be our warpcast.compute header. And let's see, our API key here we'll make sure is as a string. Then below here, we're going to set our method here to get method. Then we're going to get our data back, and that data we're going to await our response. Once we get back our response, we will get the JSON of that. Then we will get our response and get our response.cast.reactions. And then we are going to parse. So we'll get our reaction schema and parse. And finally, we'll return the data back. So that, again, should fetch us our reactions. Now we need to check our reactions and see if a user has recasted and liked our specified cast. So we're going to create a public static async here, and this is going to be called has recasted. This is going to take a FID number, which is going to be a number, and check if a user has recasted that specific cast. So we're going to get our reaction here, which we're going to await, and we're going to use warpcast.fetch all reactions. And then we're going to here return our reactions.recast.sum, and we're going to check if the recast.fid matches a FID that we pass it here. Then we're going to do the same thing with has liked, except this time we're going to get the likes. And then again, check if a FID has a like, and FID matches, and it will return to us if that specified user has liked our cast or not. Finally, down here, we need to create one more function here to validate our message. So this is going to be a public static async here. This one's going to be called validate message. We're going to get back our message. We'll say message bytes here, which is going to be a string. This, we're going to have a new URL for our API here, which is going to be our API URL /v2/farcaster/frame/validate. We're going to get back our response here, which we're going to fetch our URL. We're going to set our headers here, which will be our warpcast.compute default header. Method is going to be post. We are going to give it a body here, which we are going to set here to our message bytes in hex is going to equal our message bytes, which did I spell wrong? Yeah, message bytes. There we go. Then we're going to get our data here, which is going to await our response. It'll then get the JSON here. Then we will get our response. And then we're going to validate.messageschema.parse. And then we will return our data here. Actually, we'll return data.action. There we go. And then we'll use this, and we'll be able to also get the wallet that we need to send the NFT to. So again, this is just going to be our class here for our warpcast. Again, checking all the reactions to make sure that a user has liked and recasted our specified cast, along with validating the frame message, along with being able to validate the frame message. So now that we have, we set up the ability to check the frame, to check the requirements in order to mint NFT. Next, we need to create the actual API call to thirdweb engine to mint the NFT. So in my files here, I'm going to create a new folder in our source folder here called API. I'm going to create a new file within that, and I'm just going to call this one fetcher.ts. And in here, we're going to do similar to what we did for our warpcast class here. We're going to create our API call to engine here to mint the NFT, to also check the NFT balance to make sure the user can't mint more than one. So we're going to create our mint response schema. This is actually going to be a object. So we're going to import z from, and then we're going to get back our results. And this is going to be a z object. And this is going to give us back a queued ID, which is going to be a string. We're also going to get the owned response, which is going to be an object as well. This is going to give us back our result, which is going to be an array of object. And this is going to give us the owner, which will be a string, and it should be an address. So it's going to say start with 0x, type, which is going to be a string, and then the supply, which is going to be a string as well, actually. So once I have those two schemas set, we're actually going to open up a terminal here, and I'm going to run yarn add at thirdweb-dev/engine. And then with this, we're going to get our instance of engine here. So we're going to say engine equals a new engine. Oops, not set engine, new engine. Then we'll import this here. So we'll say import engine from at thirdweb-dev/engine. Now engine to set here, we're going to need the URL, which is going to be in our config file. So config.thirdweb.engine.url. Then we also need our access token, which is going to be our thirdweb.engine.access token. We'll make sure this is as a string. Same thing here with the access token as a string. So now that we have that, we can get we're going to check the balance of the owned NFTs for the user. And then we'll also create a request to mint the NFT. So we're going to create export const, we'll say fetch is owned, which is going to equal an async. We're going to take the receiver, which is going to be a string. And we're going to get our response here, which we are going to await engine dot, we're going to say ERC 721 dot get owned. And this is going to give us back again this is going to give us the supply of owned NFTs a user has based on our contract that we give it. So here we need to give it a wallet address, which is going to be our receiver. Then we need to give it the chain, which we're going to get from our config file. So config.contract address. Sorry, we need to do chain ID, I think, first. Get owned. So chain ID. So under our config, we'll get the thirdweb.chain ID, and we'll say to string. Then we'll get the contract address, which will be under the config.contract address as string. Then what we're going to do here is just return our owned response schema, and then we'll parse that with our response that we get here. Then we need to create one for our mint. So we'll say export const, we'll say mint NFT. This is going to equal an async function here, and it's going to require our receiver, so who is receiving the NFT, which will be of type string. And same thing here, we're going to get our response, which is going to await our engine. We're doing this on the ERC 721 contract. Of course, this, depending on the contract type that you decide to use, will be different, but we're going to also do the claim to. And with claim 2, we supply it to the chain, which we're going to get our config.thirdweb.chain ID to string. We're going to get the contract address, so our contract address as a string. We're going to get the backend wallet from thirdweb that we're going to be using from engine. So we're going to get our config.thirdweb.engine.wallet as string, and then we need to give it our body here, which it needs the receiver, which is going to be our receiver here, and then the quantity, we're just going to say 1, and it has to be a string like this. So this is going to be our response or request to mint an NFT, and then we're going to return here our mint response schema dot parse, and then we're going to parse that response right there. So again, this is going to be us utilizing engine here to check the NFT balance to see if someone owns the NFT, and then the ability to mint the NFT using engine. Next, we're going to create one more class here. So in our classes folder where we created that warp class, we're going to create a new file. We're going to call this thirdwebengine.ts. And in here, we're just going to export a class here called thirdwebengine. And in here, we're going to have a public static for getting is NFT owned, which is going to take, which is going to equal an async, and take our receiver, which is going to be a string. And all we're going to do is get our response, and we're going to await thirdweb engine. We're going to await fetch is owned and give it to the receiver. We're going to import fetch is owned here, and then return if our response dot result dot length is greater than 0. Then we'll create one for our mint. So public static, we'll call this mint NFT. Again, it's going to take the receiver of who we're sending it to. This is going to get our response, which we are going to await mint NFT and give it to the receiver. Make sure we import the mint NFT as well. We have it as lowercase, so mint NFT, mint NFT. And then get rid of this. There we go. And then we're going to return the response here. And that's it for our thirdweb class. So final thing we need to do is create our Mint API. So we're going to come back into our pages folder. In this API folder here, we're just going to rename this hello.ts to mint.ts. And I'm going to take all of this and delete it. Well, actually, we can get rid of this here, get rid of that data, and then we'll get rid of what's in here. So first thing we're going to do is create our request body warpcast schema. So this is what we're going to be getting back from warpcast here. We'll make sure we import that. Import Z. And then we're going to also create a request query schema. And depending where we set this, so start will display a recast to mint and like to mint. So this is going to be where we display, hey, you need to go and so this is going to display our starting point where we have to say get started, and then to like and recast our cast. Recast is going to be where we check to see if a user has liked and recasted it. And then the mint here, if they reach this query here, that means that they'll be able to actually press mint and mint the NFT. So we're just setting those as like states of start, recast, and mint. I'm going to yarn add Next.js cores here. So we'll drop that down. And what we're going to do first is set that up. So we're just going to say, let's make this async and then import this. So we just make sure that we allow methods to get and post, and we'll just set the origin to any here. And we're just going to check if request method equals post, or does not equal post, sorry. We're going to return a response of status 400. And this is just going to send a invalid method. Then we'll run a try catch. Now for the catch, we're not going to actually error it out. We're going to return a response of status 200. But we're going to set the error on the button itself on our frame. So we're going to send, and we're going to put compute HTML here. And again, we're going to give it our image path, which we're going to set to just be our image, but you can put like an error image or whatever image you want to reference there. We're going to set the post type. So we're going to set it back to start. And then we're going to change the content, which we're going to have it say, something went wrong, please try again. So again, if an error happens, it'll just change the button text to this text right over here and restart our post type back to the start. Now here, we're going to get the type of response that we are on. So type here, which is going to equal our request query schema. And then we're going to, again, find out if we are on start, recast, or mint. We also need to get back, we're also going to get our trusted data, which is going to be our request body warpcast schema. And then we're going to get back our action here, which we are going to await warpcast dot validate message, and then give it our trusted bytes. From there, we'll get back our action, which we'll be able to get the connected wallet address with. So now if we are on start, so if type equals start, means we're just starting off. We need to check if the NFT is owned and if a user has liked and recasted. So on the start, we're going to check one, if the NFT is already owned by the connected user. So we're going to get is NFT owned. This is going to equal await. We're going to use thirdweb engine here, dot is NFT owned. And then we're going to give it our action dot interactor. Did I not interactor dot custody address? Make sure that our warpcast here is actually set up correct. action interactor, yeah, and then custody address. Okay, that is correct there. And then if the NFT is owned, we'll give it a response here and set the post type to start and say you already own this NFT. And then if they don't own the NFT, then we'll put return. We'll say response status 200. And then we're going to compute, set this to recast. And then say that they have to recast. So we'll say, not recast, we'll say like, and recast to claim. Next, we'll set if they are on recast. So if type equals recast, we're going to get if they have recasted and liked the specified cast. So we'll say has recasted, which is going to await. And we'll say warpcast dot has recasted, which we're going to give it the action.interactor.fid. And then if they have not recasted, then we will set this to recast, and we'll say recast required to mint. We'll do the same thing for like. So we'll say has liked. So we'll use our has liked here. And if they have not liked it, we'll say like is required to mint. And if everything is good, we change the post type to mint, and then we say mint your NFT. And then finally, if type equals mint, we are going to await thirdweb engine dot mint NFT, give it our interactor custody address, and then we are going to return a response status of 200. We'll set the post type back to start and say, congratulations, your NFT has been minted. So again, this is going to be our API call here. This is where we're going to point our Farcaster frame to, and it's going to check and make sure where we are within the process of our frame. And again, it's going to use the functions that we created to see if a user, one, owns the NFT, because they can't claim more than one. It'll then check if they have liked and recasted our specified cast, and then they'll be able to mint the NFT. So now that we have all of that set, I'm going to open up my terminal here, and I'm going to run a Vercel and deploy our frame. So yes, we're going to deploy our requirement frame. I'm going to deploy it to my account here. No, it is not an existing project. We'll just name it requirement frame, and then we'll set that up, let that build and deploy. No, we're not going to modify any of the settings. So we'll just open this up here. There we go. Our project is building and deploying. While that is going, we're going to come back to our project here, go to the settings, and we're going to set up the environment variables. So these environment variables here are going to be the environment variables that we have posted in our config file. So again, we're going to have to set all these up. So we're going to need our Neynar API key. We're going to need our next public contract address. We're going to need our warpcast hash. We're going to need our URL. We're going to need our chain ID. We need our thirdweb engine URL, the thirdweb engine backend wallet, and we need the thirdweb engine access token. So you're going to fill in all these variables here. If you don't know what your engine URL or engine backend wallet is, again, we'll add some links down in the description below to see how you can set up your own version of engine or instance of engine. You can also get your own instance of engine through thirdweb. It's $99 a month as of making this video, and you can check that out as well. Contract address, the warpcast hash. So for this example here, we're just going to use my test cast here. I'm just going to unlike and unrecast this. So you just select the cast that you want, copy the URL. Easy thing to do is come over to Neynar here under the cast, retrieve cast for a given hash. Just paste in the identifier the URL and hit try. You'll be given back the cast hash right over here. So you just need to copy that cast hash, and that's what you're going to supply for the warpcast hash. So whatever whatever cast you want to require the like and recasting of, that's what you're going to put right over here. So I'm going to fill in all my environment variables. We'll head back to our deployment and then do that. And then for the host URL, it's going to be the URL that you host the frame on. And once you have that set, we'll come back to deployments here, and I'm just going to redeploy this here and make sure that my environment variables take place. Once that's done, we'll take the domain here. We'll go back to the frame validator and test out our frame. So come back to the frame validator by Workcast here. We'll paste in our URL. We'll get rid of the /mint. We'll load our frame. You can see here our frame loads. We have our image. We have our button, everything looks good. We can test this out. So you can see here that we have to like and recast to mint. So if I try this, you can see a like is required to mint. So we can go back to our cast. I can make sure I can recast and I like this. We'll come back to our frame here. We'll try it again. You can see now I can mint the NFT. If we hit mint, you can see congrats, the NFT is sent to our wallet. If we look at our engine here, you can see that we have a transaction queued up. Engine is taking care of all the on-chain transaction behind the scene. You can see it is sent, and then we'll wait for it to be mined. We take a look at our contract here, our NFT contract, come back to our NFTs. You'll see that one has been claimed, and our wallet address here is showing that our Farcaster account now owns the NFT. I come back here and I hit this button again. You can see here, it says I already own the NFT. And there you have it. We built our own Farcaster frame that allows a user to mint an NFT. Not only that, it requires them to like and recast a certain cast before being able to claim the NFT. We also made sure that a user can only claim one NFT. With that, you're able to create these creative and unique Farcaster frames utilizing thirdweb's engine and using Neynar's API. So again, I hope you folks enjoyed this video. If you found some value in it, don't forget to give this video a thumbs up. Hit that subscribe button and don't forget to turn on the notification bell so you don't miss out on tutorial videos just like this. If you have any questions or you need any support, we'll drop a link down in the description below. You can open a support ticket and our support team will be happy to help you out and answer any of your questions. But again, I hope you folks enjoyed this video, you found some value in it, and until next time, see ya.